Alright, so in the last video I covered Ceva's theorem, so what we're going to do now is we're going to prove the converse. So as the statement, as you can kind of see on the recording, is that we've got a triangle, we've drawn all the Cevians, and basically it says that if the equation is satisfied, then the three lines are concurrent, the three Cevians are concurrent. And so the proof idea here, which might be new for some of you, is that what we're actually going to do is that we're going to assume that our three Cevians are in place. Then we're going to assume there's a fourth one, and then show that it's actually still one of the remaining three. And so the overarching idea is basically a uniqueness proof, in the sense that basically we're trying to show we start by assuming there is more, in this case, more than three objects, so we're going to assume there's four objects, and then we show that in the end that fourth object is the same as one of the three. So so it may seem a bit weird, and in other areas of mathematics with uniqueness proofs, mostly it's like assume there's two objects and then you show they're the same. So the same idea is gonna follow here. So we're just gonna do this in terms of like just demonstrating like what actually happens. So we've got the diagram, we've got the Cevians drawn, and instead of y, I've got a y dash, and just to be consistent with the notes. So what we're gonna do now is that we're gonna suspend our sorry, I keep messing up the phrase, suspension of disbelief. So you're gonna suspend your disbelief at the moment, and then we're gonna assume that there is a fourth line. We're gonna assume there's a fourth line that b to y, where y dash is the existing one, and then y is the new point. But we're also going to assume that it also satisfies Ceva's theorem. So what we know by definition and from establishing the diagram is that we have AZ over ZB, and then that's going to be times, sorry, this is going to take me a while, BX over XC times CY over YA is equal to 1. So that should be Y dash. So that's the original diagram. And then what happens is that because we are assuming, so I guess we assume there exists a fourth Cevian, in this case this is by, that also satisfies in this case this equation, which I'm too lazy to write out again. So now, by that assumption, what that actually means is that we can also establish that we've got AZ over ZB, and then BX over XC, and then CY, and it suddenly made itself a circle for some reason, which is lovely. Alright, let's try this again. BX over XC, and then CY, this is normal Y, not Y dash, over YA, and it's also equal to 1 because it satisfies the theorem we established earlier. Okay, so, and effectively what happens is that we're going to make them equal each other, which is as boring as it can get. So we're going to make them equal to each other, so that we get AZ over ZB, and then BX over XC, CY, YA. So that's going to be the first one, this Y dash, and that's going to be equal to AZ over ZB over BX over XC over CY, and then YA. And as you can imagine, what happens next is that we're just going to cross out the common factors, or well, I shouldn't say cross out. We are technically dividing by those ratios, and we are left with CY dash over YA, Y dash A. Oh, I forgot the Y dash there. There's Y dash A, and then the other one is also going to be CY over YA, which implies that Y is equal to Y dash. And we are done, effectively. So, and sorry, I just realized my webcam was blocking the what's the name. Okay, so it's well, at least with this one, this is that simple. Other uniqueness proofs, at least when you learn it for the first part, are also relatively simple. So that's the core idea. You don't really need to memorize the proof so much. It's more about kind of just saying, okay, here's another way that we can kind of look through the proofs, and here's an example of a uniqueness proof, in which, once again, the main idea is that we assume there is more than the number of objects we start with. So in this case, we assume there's 4 Cevians, and then we show that we show that the fourth one is equal to one of the other 3. And so effectively, you can apply the same ideas. So next, what are we doing next? So we're looking at other Cevians, and then we're gonna be looking at a few more different theorems. So until then.